This video is the first in a series of videos looking at the data analysis stage of the research process. And in this video we will be talking about quantitative data analysis. And there are two types of quantitative data analysis. There's descriptive analysis, where you simply want to describe the data you've gathered, and there's inferential data analysis. And that's when you want to use the data you've gathered from a sample of people to represent the whole population. We're going to focus today on descriptive analysis. There are lots of different ways that you can present your information. We're going to look at a few of these. We're going to start with the mean, the median and the mode, which are all measures of the average. The mean is calculated by adding up all the numbers you have got and dividing by how many numbers there are. The median is the middle number when the numbers are in order of size, and the mode is the most common number. Let's just look at an example of this. Here we can see the income distribution for the UK population in 2010-2011. And there's an interesting distribution that we can see on this chart. At either end there are not very many people, but just to the left of the centre the figures have gone up dramatically. Because this isn't actually symmetrical, it means that if we calculate the mean, the median and the mode, we will get different values. So if we look at the modal value, which isn't indicated on the chart, but it's the highest bar, £235 a week is the average or mode income. If we look at the median income, we can see that that's £359 a week. And if we look at the mean income, it goes up to £443 a week. It would be correct to give all of those different values as the average value. The mode ignores how many people are earning more or less. So it doesn't necessarily represent the whole population. The mean value is taking into account, as part of the calculation, those people that are earning extremely large amounts of money per week. So in this case, the most representative income is the median income of £359 a week. Whenever you read average, ask yourself which average it's referring to, because it can make a very significant difference. All these show us is the central point of the data, the middle point of the data. If we look at the standard deviation, this can take us a step further and allow us to look for how spread out the data is. If we look at this first diagram, this is the data from the results for a research module at UCB a few years ago. You can see that some people didn't hand in, not many, but just some, and they got 0. Somebody handed in and got 90%, but the vast majority of people got between 42 and 78% as their marks. And you can see on there that most people, the mode, got 60%, and it's very symmetrical distribution around that. That's what we would call a normal distribution. It's a bell-shaped curve. This affects statistical analysis later on. If we look at the next chart, we can see that the first clustered data set is a tall, narrow bell-shaped curve, and the second one is a much wider and lower curve. When we calculate the standard deviation, we're measuring a value of how spread out they are. So the dispersed data set, the second one, is much more spread out and therefore has a larger standard deviation. So the bigger the standard deviation, the more spread out the data. In fact, we can use this calculation of standard deviation to make some assumptions about the population. If we look at the next chart, here we have an example of a normal distribution. You can see the bell-shaped curve there. If we use the mean, this figure gives us a starting point, and if we want to work out the range between one standard deviation below and one standard deviation above, then you can see from this chart and the blue arrow that 68% of the population will be within that range. Between -2 standard deviations and +2 standard deviations, there are 95% of the population. And between -3 and +3 standard deviations, 99% of the population. So if we go back to our first chart, if I were to tell you the standard deviation was 5 and the mean was 60, we could work out what 68% of the students achieved. So that would be the mean minus 1 standard deviation, 60 minus 5 equals 55, and the mean plus 1 standard deviation, so that will be 65. Between 55 and 65, there were 68% of the students. If we want to take its 2 standard deviations, between 50 and 70, there were 95% of the students. So very, very few scored outside of that range. So standard deviation tells us a little bit more about the data in terms of how spread out it is. Let's look at another way of understanding and describing the data. Let's talk about the interquartile range. This requires you, with your data, to divide it into 4 equal sections once the data is in order of size. So let's just look at a very simple example. We here have some numbers. If we divide it equally into 4 parts, the line, the divider, goes through 4, 5 and 8. We call the first one the lower quartile, or Q1, and the last one the upper quartile, or Q3. What we can tell about the interquartile calculations is that quartile 2 will always be the middle or median value for our data. So we have our data and it's divided into 4 equal sections. The interquartile range is the range from quartile 1 to quartile 3. Before we move on, just a word of caution. Sometimes when you look at your data, you will have data where the middle point or the quartiles fall between 2 values, in which case you average those 2 values. So in this case, the middle quartile would be 5.5. So going back to this example, the interquartile range is going to be 8, quartile 3, minus 4, quartile 1, which gives us an interquartile range of 4. 50% of the data in our sample is in a range of 4 figures. Let's look at a way we could represent that graphically, looking at this box and whiskers plot here. If you look at the table above, quartile 1 was 4, and you can see on this chart that the box, the left of the box, Q1, is 4. The upper quartile is 8, and the right hand side of the box is at the value 8. And the median is 5, and there we can see the median represented by the line down the middle of the box. The highest value we have is 8, and so the box doesn't go past the number 8, and the lowest value we have is 3, so you can see there's a little whisker going down to the value 3. How does this work in terms of comparing data? If we look at this data showing the hourly income of Birmingham residents, you can see that the whiskers show us the range of the data. The boxes show us the middle 50%. So we can see, for example, part-time men's data is more squashed up than full-time men's income. And we can also see the median values. That's the lines on the box. So we can see the median value for part-time men is slightly less than the median value for part-time women. So we can use this box and whiskers plot to look at and understand and compare our data. We can also present our data using charts and graphics. Here's a very quick summary. You can use a bar chart if you want to compare data, a pie chart if you've got all of the data and you want to divide it up, a line chart to show change over time, or maybe simply just a table to present the figures. We've already mentioned the box plot and how that can show the distribution of data. Let's just look at an example. Here we can see the labour force survey for the Office of National Statistics, and this is showing the unemployment rate for 16 and overs that's been seasonally adjusted, and it's showing the percent of all economical activity. It looks on this chart as if there's not a lot of change from 2008 to 2013. It looks very level in terms of the chart. What we can see is the labelling of this chart is very poor, and we should use the information that we've got to label it better. If we look at exactly the same data on this second chart, it looks rather different. It looks like it's going up and down a lot more. And one of the reasons for that is, if you look on the left, you can see that we've changed the scale, so it starts at 6% rather than at 0. And that emphasises change by making that adjustment. So be careful when you're looking at or creating charts to represent them fairly. These other two charts are also from the very same data, but they're showing very different things. So again, you can use data to put over a particular point of view if you don't use it properly. So when you see charts, consider whether or not the data is a fair representation, or have they just selected part of the data to show their own viewpoint. Percentages are a way of showing the data in a more straightforward, easy to understand way. If I said that 61 out of 134 people said that they didn't enjoy their lunch, then it's quite hard to picture that amount. But if I said 48%, then I know it's just under half. So percentages can simplify the figures that you're using. And there's two calculations that are noted here: percentage share and percentage change. You'll be looking more at these in your practical lesson. One more descriptive area that I'd like to touch on is using cross tabulations. Here we've got a chart And what we gathered was information from a number of people, in fact from 200 people, about their gender and their income. And then we've summarised it on this table. Rather than just looking at one of those questions, gender, we've looked at both compared to each other. So we know how many men earn less than £15,000, how many women earn less than £15,000, and so on. Looking at this table, it would seem that more women than men earn less than £15,000 and that more men than women earn over £30,000. So that suggests that possibly men earn more than women. The issue here though is that's only based on a small sample of 200 people, and we don't know for sure if that 200 people represents the population. If we look over at inferential statistics, if we want to know if there's a relationship between two different groups or variables or data sets, then we can do this pivot table or cross tabulation, which we have here, to see if it looks like there is a relationship, but that doesn't tell us there is a relationship. To do that, we need to move on and do a statistical test on this data to investigate it further. We will talk about inferential statistics in a later video. Whatever you're doing, however you choose to present your data, make sure that everything is fully labelled with the units, what the data's about and where it's from.